It was the fastest commercial airliner ever built, traveling at twice the speed of sound. A marvel of engineering, the Concorde changed air travel forever. But what made this aircraft so revolutionary, and why did it disappear? In the golden age of aviation, the Concorde stood as a symbol of human ingenuity and ambition. Developed as a joint project between Britain and France, this supersonic jet defied the limits. With a cruising speed of Mach 2.04, it could fly from London to New York in under 3.5 hours. However, the Concorde was not just about speed. It was a technological marvel that overcame significant engineering challenges. Designing a commercial aircraft that could safely sustain supersonic speeds required radical innovations in aerodynamics, propulsion, and material science. Engineers had to find solutions to extreme airframe heating, sonic boom restrictions, and fuel efficiency, all while ensuring a luxurious ride. In the 1960s, the world was gripped by the race for supersonic travel. With the Cold War fueling technological advancement, both the United States and the Soviet Union were exploring faster, more efficient modes of transport. Commercial aviation was booming, and airlines sought ways to shorten long-haul flight times. Enter the Concorde. While the conventional airliners like the Boeing 747 could fly at speeds of 560 miles per hour, the Concorde was designed to cruise at twice the speed of sound. This meant that a New York to London flight typically took over 7 hours but can now be completed in 3.5. Business execs and world leaders could attend meetings across continents and return home the same day. However, achieving such speeds required revolutionary engineering, as traditional aircraft designs couldn't withstand the immense forces and temperatures with high-speed travel. One of the most distinctive features of the Concorde was its delta-wing design. Unlike traditional swept-wing aircraft, the delta shape was optimized for high-speed flight, providing greater lift at supersonic speed and reducing drag. This design allowed the Concorde to maintain stability and efficiency even at 60,000 feet. It also helped to reduce turbulence. The aircraft's slender fuselage played a crucial role in minimizing air resistance. Unlike wider-body jets that prioritize passenger capacity, Concorde's narrow structure helped reduce drag, ensuring max efficiency. Another key innovation was the droop nose mechanism. Since the delta wing design required a high angle of attack during takeoff and landing, visibility from the cockpit was limited. Engineers solved this by designing a movable nose cone that could tilt downward during low-speed operations. Powering the Concorde were 4 Rolls-Royce Snecma Olympus 593 turbojet engines, originally designed for the military. These engines were among the most powerful, generating 152,200 pounds of thrust. What sets them apart from traditional jet engines was their ability to maintain efficiency at supersonic speed. A crucial feature of these engines was the afterburners, typically found in fighter jets. The afterburners injected additional fuel into the exhaust system, providing the extra thrust needed for supersonic acceleration. However, this also meant high fuel consumption, one of the Concorde's biggest drawbacks. It burned around 25,600 liters of fuel per hour, significantly more than subsonic aircraft. Managing the heat generated by these engines was another challenge. At Mach 2, air entering the engines needed to be slowed down to subsonic speeds before combustion. This was achieved using variable air intake ramps, a sophisticated system that controlled airflow to ensure optimal performance without overheating. Flying at Mach 2 posed an entirely new problem: extreme heat. With friction, the Concorde's aluminum skin would heat up to 127 Celsius during flight. Unlike conventional aircraft that operated at lower temps, the Concorde's engineers had to develop materials that could withstand this. Instead of using titanium, which was expensive and difficult to manufacture, the engineers chose a special aluminum alloy that could expand and contract during flight. The thermal expansion caused the fuselage to stretch by up to 30 centimeters or 12 inches, a phenomenon that had to be factored into the aircraft's design. To further manage heat, fuel was used as a coolant. The engineers designed a system where excess heat from the skin and engines was transferred into the fuel tanks before combustion, preventing critical overheating. These innovations ensured that the Concorde could sustain supersonic speed for extended periods with no compromise to safety or performance. One of the biggest limitations of the Concorde was the sonic boom, a powerful shock wave produced when an aircraft surpasses the speed of sound. The loud, thunderous noise could be heard for miles and caused significant concern. Because of this, aviation regulators banned supersonic flight over land, restricting the Concorde to transatlantic routes such as the London to New York and Paris to New York. This limitation significantly reduced its potential market and revenue. Beyond noise pollution, Concorde was also extremely fuel inefficient, consuming far more fuel per passenger than conventional airlines. It burned approximately 6,770 gallons of fuel per hour, making it one of the least economical jets ever built. In contrast, newer wide-body jets like Boeing 747 could carry more passengers and greater distances with greater fuel efficiency. Additionally, Concorde's high carbon emissions raised environmental concerns. The beginning of the end of the Concorde came on July 25, 2000, when Air France Flight 4590 suffered a catastrophic crash shortly after takeoff. The disaster was triggered by a chain of unfortunate events. A piece of metal believed to have fallen off a Continental Airlines DC-10 that had taken off minutes earlier was lying on the runway. As the Concorde accelerated, one of the tires struck the debris, causing the tire to rupture. Fragments of the tire were flung into the aircraft's wing, puncturing one of its fuel tanks. A massive fuel leak ensued, igniting a fire near the left engine. Within seconds, the aircraft was engulfed in flames, losing thrust on one side. The pilots attempted an emergency landing, but with its engines failing and severe structural damage, the aircraft crashed into a hotel in Gonesse, France, killing all 109 people on board and 4 people on ground. While the accident was not directly caused by a design flaw with the Concorde, it raised serious concerns about the aircraft's safety. The investigation revealed that the fuel tanks were vulnerable to punctures from tire debris, leading to crucial modifications such as Kevlar reinforcements in fuel tanks and stronger burst-resistant tires. However, despite these changes, public confidence in supersonic travel was severely shaken. Even after the fleet was cleared to fly again in 2001, Concorde's elite customer base had dwindled, and many wealthy travelers began to question its safety. Beyond safety concerns, Concorde was becoming increasingly expensive to operate. As the fleet aged, maintenance costs surged, with each aircraft requiring extensive servicing and part replacement. Unlike modern jets, which benefited from newer materials and efficient maintenance cycles, Concorde's outdated tech and hand-built components made repairs complex. The situation worsened following the 9/11 terrorist attacks in 2001, which devastated the airline industry, leading to a sharp decline in air travel, especially in luxury and business class markets. Many high-paying Concorde customers, corporate execs, and celebrities opted for private jets. Meanwhile, the aviation industry had already begun moving toward more cost-effective, fuel-efficient long-haul aircraft. The rise of twin-engine jets like Boeing 777 and later the Airbus A380 demonstrated that airlines could carry significantly more passengers over longer distances at a fraction of the cost. The Concorde could only seat 100, with a Boeing 777 carrying 300 to 400 passengers. The economics no longer favored Concorde. Its astronomical fuel consumption, high ticket prices, and restricted routes meant it could never turn a significant profit. Facing a perfect storm of safety concerns, low passenger demand, and rising costs, British Airways and Air France jointly announced the retirement of the Concorde in 2003. On October 24, 2003, the final Concorde flight landed at London Heathrow, marking the end of the world's first and only successful commercial supersonic airliner. Although it was a technological marvel, Concorde had become a relic of a bygone era where engineering ambitions sometimes outpaced economic viability. Although Concorde was retired, its legacy remained strong. It was a symbol of engineering, brilliance, luxury, and speed, proving that supersonic commercial travel is possible. Many of the innovations like advanced aerodynamics, high-altitude flight capabilities, and supersonic engine design continue to inspire modern aircraft development. Today, several companies, including Boom Supersonic, NASA, and Lockheed Martin, are working on a new generation of a quieter, more fuel-efficient supersonic jet. Projects like the Boom Overture and NASA's X-59 Quest aim to revive high-speed air travel while addressing the noise and environmental challenges. If successful, the aircraft could usher in a new era where flying at twice the speed of sound could become a reality once again. If you enjoyed this breakdown of the Concorde's insane engineering, don't forget to like and subscribe for more deep dives into legendary machines.